Now you'll notice that I haven't talked about C, the change, and that's because it deserves its own special recognition. Not because we ever ask you to tell us what the change in a process is, but because it's absolutely the essential thing you need to know if you're going to be able to get from how something starts to how something ends. So you'll notice what I've got down here in the middle is this middle letter C from the Rice expression. It's the amount of material that's different between how you started and how you ended. If you started with 2 molar and ended up with 1 molar, then the change is 1 molar. If you started with 7 molar and ended up with a half molar, then the change is 6.5 molar. But notice that because the reaction can go to the left and to the right, I never know what my change is going to be. So I have to put that plus or minus there. And then I have to do a Q versus K comparison. And if it's Q less than K, then I know the reaction is going to shift to the right. Then my equilibrium amount is going to be greater, so I have to put a plus here, and so on. So this right here is the Rice expression. This is the thing that we try to fill in when we are performing our equilibrium calculations. Notice that as I fill them in, I am able to talk about K as being the ratio of the bracketed equilibrium concentrations, Q as being the ratio of the starting or analytical concentrations, the non-equilibrium concentrations. And I spend the rest of my life calculating Q, calculating K to figure out if the reaction is going left or right, and that's going to tell me whether or not I am subtracting or adding amounts to the change.